Okay, remember the Def-Tech 4000 that was mailed into me and I didn't think all the components were there? Well, I was right. So this is the bottom of the subwoofer, and normally it has adjustable feet that go on here, but this one does not include that. I don't know, the customer might have just removed them, but they did send this. I have it on a piece of foam rubber because look at that piano black finish, and I don't want to scratch it, even though it is the bottom of the unit. Now the customer did mail me the whole enclosure with the speaker. And in case you were interested, this one does have a 3 ohm resistance voice coil, which means it's probably close to a 4 ohm impedance. Get my drill ready here. And let's go ahead and pull, I believe this is probably the main power amplifier. We'll get that pulled off the board because this is where the AC goes in right here. And that's what I was missing. And, oh, nope, there's only one way to put it back together. Okay, so let's go ahead and get this thing disassembled. Let me safely stow this away in the customer's original box. Yeah, and just in case you were wondering, here is the inside of the speaker enclosure. There is the huge subwoofer. It looks like only about an 8-inch subwoofer. But just look at the size of this thing. It's got some numbers on the bottom of it there. I'm a little disappointed in the size of those connectors right there, but it does have 2 passives, one on each side, and it probably weighs 10 pounds. Double magnets. I'm sure it's got a very, very long throw voice coil. And I don't know if you can see it, but they did this little jump on the spider with the lead-in leads so they don't get fatigued just hanging loose at 20, 30, 40 hertz. But I just want to show you this enclosure. I do have all the piano black removed from it and safely stowed in the customer's original box. This is the bottom where the amplifier would mount because you can see the screw holes there, and then there is the output section that I measured the fets on, and it was perfectly fine. Now over here on the other side, this is where the top actually goes, and it just clips on, so I removed that safely so I don't scratch it up. But yeah, pretty nice. I really, really hope I can get this thing going for the customer and make him happy. Okay, so I'm just going to start by removing the 4 perimeter bolts, and I think that one may connect to the case as well. And yes, it does. You can see the little standoff right there. So let's go ahead and get these things out of here. And now I'm not worried about getting a shock from the possible filter capacitors because it's been discharged, well, for, whoops, didn't follow my own rules. It's been discharged for the good part of a year at this point. That's how backed up I am. Okay. Got that open. So remember, this thing was totally dead and it had a blown fuse. So I'm looking around. There's a couple of switching fets down in here. And just one big old switching transformer. Ferrite core, I would imagine. And I'm not seeing any apparent problems right off the bat. Not seeing any bad solder connections. Everything looks pretty doggone good. Well, let's get a little bit further into this thing and check the fets. And I want to go ahead and check between the line and the neutral to see if we may have a short there. I'm sure there's going to be a bridge rectifier somewhere. There's a class, I think it's a class Y2 capacitor possibly. X2 capacitor, my bad. Bridge rectifier right there, may be an issue. big filter caps, 820 at 200 volts, and then the switch mode power supply to output the voltage that the power amplifier needs. And the good news is I checked the fets on the power amplifier in the previous episode, and there were no shorted fets, so I'm very happy about that. Okay, well, let's go ahead and do some basic checks right now and see what happens. All right, hopefully you can see the voltmeter there. Yeah, it looks okay. All right, so first I just want to check between live and neutral and see if I have a short. I'm going to verify lead integrity, not by touching them, but going the solder to solder, and I've got 0.2 ohms, so that's good. And I've got, without touching anything, I've got 40K, which is probably a function of that X2 capacitor right there. And then I just want to verify that live does connect to one of these two center pins on the bridge rectifier. Connects to that one. That one is open. Neutral should connect. Wait a minute. Okay. All right, my bad. So live connects to that one. Neutral connects to that one. Next, I want to check the output and see if we have a short. And yes, 8.1 ohms. That is going to be the problem. That's what blew the fuse. Why do we only have 8.1 ohms on the output of the bridge rectifier? It's going to feed into these caps. So do we have a shorted cap? I kind of doubt it, because they are a positive and negative capacitor. Yep, caps are good. I think we're going to have a shorted FET. So these things are set up that the gate is on the right hand side. So I'm just going to check source and drain, and I see 0.2 ohms. Source and drain on this one, and 0.3 ohms. That's going to be the problem. Shorted driver FETs for the switch mode power supply. Right here, there's a switching transformer. Optical isolators to feed back the signal. And the FETs mount on the opposite side of this board right here. So I need to get this board out. And you can't even see them. They're way down. There they are right there. Need to get this board out and look around and see what possible associated components might be bad. There is a stand-up circuit board right there. And I'm sure it's just nothing but surface mount parts and surface mount capacitors. I certainly hope not. Okay, well, I'm going to get everything unsoldered, and we'll come back once I have basically this heat sink off of the board so we can take a look at the bottom of it. One moment. Okay, well, there are the output FETs. Let's go ahead and move the circuit board out of the way. I'll get the voltmeter set back up here, back to ohms. And we'll just do a source drain ohm check. 0.2. And that one actually checks good. So we have just one shorted FET. In basically all directions. So let's go to diode, and we'll go ahead and check the other one and see if it actually tests good or not. So I get 0.498, 499. So let's see, we'll turn that. Try to turn it on and off. Okay, there's 210. This should be 0.5 again. And then this should turn it back on. That was my bad. I shorted 210 off 0.499. So the FET is actually functioning. $933 in that direction. And this should be open now. And yes, it is. On. 934 in that direction. And this should be off. And it is open. So that FET actually, according to the voltmeter, checks okay. Hopefully you can see that on the screen. Let's go ahead and zoom in on these FETs and see what the original part numbers are and if I can even find them, because Definitive Technology is, I don't know, they use off number FETs that are extremely hard to track down. I did manage to get some for the SuperCube 2 and 3s. Yeah, it's been a nightmare. Okay, one moment while I put this thing in macro and zoom in. Okay, well, it's really hard to read, but it is a 26 N as in Nancy, M as in Mike, 60N Nancy. And I really can't see that one at all. Let me try to shine an LED light on it. Yes, 26NM60N. They're ST branded FETs. So that one is the good one. Date code CZ04KCMAR706. And looks like the same date code, although the, I guess the C is the same. I would expect them to use a matched set if possible. All right, so before I look up those parts, I want to go ahead and check the rectifier diodes on the secondary side and see what they check like. Okay, cap is charging, that's good. 344, and that should be exactly the same. And this one should be the opposite. Oh no. 347, and should be the same 347. Okay, so that tells me that these caps are not shorted on the output side. This should go back to 0 and then charge up, and it does. This should be the charging up side. And this should be 347. Yes, it is. Opto. So this must, let's move this out of the way. Yeah, I see a bunch of discrete transistors down here feeding one of the two opto isolators. Maybe that's what turns on the power supply when the digital board or the preamp requests power. It does some kind of level shift, possibly. I'm not too terribly sure. So it shows it has fuses, but it just has a jumper in place because this one has the fuse on the back panel. All right, well, I need to do some basic tests down here. There's a bunch of discrete transistors, which is a good thing. Let's see when it loses focus. We'll back it off until it regains focus. There we go. So I need to test. So right here where it says Q1, that's the gate, and that's the gate drive transistor. I need to make sure that that transistor is not damaged by a shorted FET, because that is a pretty typical problem. And then I see a couple of FETs right there. They are actually in parallel. If you look, it's base to base, collector to collector, and emitter to emitter. So I need to test those and see what shape they are in. Let's go ahead and zoom back out. I'll get the meter set up over here, and we'll just do a couple of quick probes on this and see what that one transistor has to say. Hopefully you can see everything. 068, not good. Open that way. Now there might be a resistor across it, but I don't think there would be one that's that low a value. And then nothing, so that is definitely bad. So in ohms, it reads 82 ohms. Unfortunately, the other one is underneath this diode right here. I believe that is going to be the reverse like EMF spike protection diode. So I'm going to have to actually unsolder that off of the board, which means I have to put yet a different tip in the Hacko so I can get to that guy. And then I need to check some resistors and make sure they're within tolerance, and quite possibly pull this little board off of the main board and do some checks on it, because that is probably going to be the controller or the driver board. I do see a couple of low value resistors right down in there. It's going to be kind of hard for you to see, but it appears that they are brown, black, silver. So they are a very low resistance resistor. And see if I can get this set up here. And we'll just do a couple of quick checks if I can find them. Yes, and they do run horizontally. So let's see, we're in ohms. What's our baseline? 0.2. And I see 0.2. 0.2. And 0.2. So the resistors are good. They're not shorted. They're probably 0.1 ohm resistors, and the meter just can't get to that low of resolution. While we're here, let's go ahead and just bring out the capacitor ESR tester. We'll power it up over here, and we can actually use this to read very low value resistors. Okay, I've just spun the leads around to make sure that they are clean. I'm going to short them together and zero it out. And we'll make sure we get 0, 0 here. And we see 0.04 ohms there. And 0, 0. And again, 0.04 ohms. Not quite sure why it reads 0.04. There might be a little inductance in these resistors too. They might be wire wound. If that does screw up the cap checker, it's really only good for non-inductive loads because it does apply a signal. But it is good for checking very low value like carbon resistors and whatnot. Okay, let me get the tip change in the solder sucker, get that diode off of the board right there, and then check that driver transistor and see if it's bad, and then we need to figure out how far back this problem actually goes. Okay, so while I'm waiting for the Hacko to warm up, let's go ahead and just do a quick ESR check on these filter caps. So I'm seeing 0, 0, 0 or 0.00. So that's solder to solder. I'm not touching the leads together. And that one reads 0.06 ohms. I'm fine with that. 0, 0. And am I not making a good connection here? Yeah, 0.07. Okay, I'm okay with that on these filter caps, which are the 820 microfarad 200 volt Yuscon filter caps. And are they 105s? Yes, they are. Well, kudos to this company for using 105 degrees Celsius caps. So the diode I need to remove is this one right there. It goes between there and there. So the solder sucker should be warmed up at this point. So I'm just going to place it on here. And because it's such a large component, I do have to wait for it to warm the component until the leads are completely broken free. And I'm moving this around to help that. And make sure the Silk screening, if there is silk screening, is correct. And what I can see is they are facing opposite directions. So I just kind of have to remember that because it might fall out. So we'll let it sit for just a moment, get all the solder molten. Hopefully we got everything. People keep asking, what am I using to desolder? It's the Hecko FR301. Just over 300 bucks, but worth every penny in my estimation if you do any kind of repair work on these things or any kind of electronics. Okay, so I've got a pair of pliers on that diode. I'm just going to rock it and unplug it just like that. So according to the nomenclature on the diode itself, it is a UF5404, which kind of sounds like a 1N5404, which would be just a general, I think they're 3 amp rated diodes at, so the 04 would be 400 volts. And I would have thought they would use something different, higher speed, but no, I'm not an engineer, so that's not my job. Okay, let's move the cap checker out of the way, spin that guy back around just like that, and get the voltmeter back into view, put it back in the diode range, and we'll go ahead and check this transistor, base to collector, and I get 68 ohms, exactly the same. Base to emitter, and I see nothing. Reverse the polarity, base to emitter, and I get open, and then in this direction I get 0.68 again. What was the other one? 80 something ohms. I'm thinking there's probably going to be an 82 ohm resistor somewhere down here. I just got to look for it. Yeah, they're both exactly 82 ohms. I find that to be highly suspicious that they both failed with the exact same resistance. Okay, so taking a look at these resistors right here, you can see over here on this side, let me put this in manual focus so it does not hunt. Okay, we're in manual focus. So as you can see, this resistor right there is 68 ohms, and it goes from the base up to this pad right there, and then that pad goes to this 15 ohm resistor and comes back to the collector. So that's 83 ohms. I'm perfectly happy with that. I'm not sure about the base on this, why I'm not reading anything, but I don't think the transistor is bad. This one exactly the same, 68 ohms. Follow this trace to that resistor, 15, and then back up to the collector. I do need to figure out why, unless they're just using this as a diode possibly, which wouldn't surprise me in the least, because I don't see anything connected to the base at all. And I don't believe that underneath this chip, this diode, I don't think there's a large enough footprint to have a plate through without me seeing it down here somewhere. Same thing on this side. There's no copper trace leaving this area, and I don't think they would want to put it underneath this. I will flip the board over and take a look at it and see if I can see anything, but I don't think that I will. I believe they're using this as a diode. Oh, I'm a dumb arse, as usual. Look at that right there. D4 and D7. They are using these as diodes. Oh, well, that explains a heck of a lot. So as long as the 68 and the 15 are not burnt, I think we're going to be okay in the gate drive aspect of both of these fets. As far as I can see right now, it's leaning more and more toward just a defective fet. So I need to go ahead and check these two transistors right here, which are the ones in parallel. Q55 and 56 it looks like, and then of course we'll have to dig this glue away. It's not conductive yet. It does not become conductive until it's very, very dark brown. To check these two driver transistors as well. There is a 2.2 ohm resistor, and I should find the mating resistor over here on this side, which I currently do not see, but it should be up there somewhere. Might just be hiding. I'm not sure what this component is right here, 66C, or yeah, it's got to be 66C. Is that a thermistor of some type? You guys let me know if you know what might be going on there, because it appears that the one end does connect to the 2.2 ohm resistor. Oh, I see a plate through right there, which means the resistor, the 2.2 ohm, is relocated somewhere else on the board, and it could just be hiding under one of these components. Okay, well, let's go ahead and start by checking these two X transistors, Q55 and Q56. Let me zoom out, and then we'll do a diode check on them. All right, so we are in the diode range right there. So let's go ahead and see if I can get my head in the way so you can't see anything. So we'll do base to collector, if it won't slip off. NSC 629, I love it. Base to emitter, 642, that is absolutely perfect. I'm going to switch the leads, so reverse the polarity. And we see 1.8 volts, which is fine. 657 base to emitter. And what were we the other direction? 642. Let's check collector emitter. I see 0.8 volts in one direction. And 0.77 in the other direction. That does not make me happy. That does not make me happy. So that means we may have a shorted or a leaky driver transistor, which we'll have to try to find suitable replacements and get those off of the board. I don't like the looks of this right now. Well, let's go ahead and dig some glue out of this area so I can check these two on that Q5 driver FET. Okay, well, I've removed just enough glue to gain access to the leads. So let's go ahead and check base to collector. 1.8 volts. Reverse the leads. 0.633. So did we get 1.8 going the other way on the other transistors? Yes, we did. Perfect. They both check exactly the same. That gives me encouragement. 659 and reversing the leads. 644. I think that's the exact value we had over here. Well, close enough. 641. And then reverse the leads again. 656. So we do see a difference. That's very good. Now, collector emitter. 805. We'll compare it to the other channel. 779. That's pretty close. Leads are reversed. 1173. And 809. That's bad. So I think we have a defective transistor on this side in the driver circuit. I can't remember what FET was actually the defective one. It was this side right here, and they do mount in that orientation. So that would make sense that it damaged the driver transistors over here. All right, so I went ahead and I pulled the two transistors off of the board right here. And let's go ahead and, well, let's do it in ohms. And we'll just check from the pads. So emitter to collector, if I can get it to stay on there, 47K. 47K. So let's go to diode. And I get open, and we'll check from base to emitter, and I get nothing. So I do see 0.645 volts in that direction. And then I should see an open in this way. And I get 1.8 volts. I'm fine with that. Let's go ahead and put some double stick tape down to the workbench and mount these little tiny transistors on it so that I can probe them and see if they are indeed good or bad. There are the two little tiny transistors out of the board, and I do have them on double stick tape, so hopefully they will not fly away. So let's just go ahead and measure base to collector, open. Base to emitter is open. I'll reverse the leads. Base to collector, 663, good junction, I like that. 667, good junction that way. Now we'll do collector, emitter in both directions. Good. So hard to get on these tiny little leads. And good. Okay, now for the other one. I think this is going to be the bad one. Base to emitter, 676. Reverse the leads. Base to emitter open. Open. Reverse the leads again. $672, that's great. And then we'll do collector. What do we do? Base to emitter. 676. Open. Whoops. Hopefully that didn't move out of the way. And open. These both test perfectly fine. Good junction, 675. Good junction, 671. Oh, they got one NPN and one PNP. Okay, I'll buy that. Huh, very interesting. Well, let me go ahead and mount these back on the board, and then I will see if I can find some replacement fets. So it's looking more and more like it's just a defective fet. Okay, so the transistors are remounted to the board, so next I will actually go see if I can find some replacement fets for this unit. Okay, well I did manage to find some replacement fets from a United States supplier. I believe it is Mauser. And here are the specs on it, and this one is going to be the STP26NM60N. RDS of 0.165 ohms and an ID of 20 amps. And yes, the STP is going to be the TO220 pack or case. And then here is the other page. Drain source 600 volts, gate source 30, drain current continuous at 25 degrees Celsius is 20 amps, and continuous at 100 degrees Celsius, or the point that water boils at sea level, is going to be 12.6 amps. Drain pulsed, I don't have a reference as to what the number 1 is right there, 80 amps. Total dissipation at 25 degrees Celsius is going to be 140 watts, which should be more than adequate. So if anybody sees any discrepancies in this, please go ahead and shoot me an email, or better yet, leave me a comment. Once again, still trying to get caught up. I went from being able to work probably in a month I'd have like 40 hours of work time, and it's down to probably like 5 at this point, just because of all the family stuff going on with my daughter. We're still, she's definitely doing better, but we're still helping out. And I've got some other personal stuff going on as well. Once again, anybody have some info, please go ahead and leave me a comment. Let me know on this video or any other video at that point. Okay, everyone, thank you for making it to the end of part 2 of the definitive SuperCube 4000. Troubleshooting this time, now that we have everything that we need. Everyone have a great day. Once again, thank you so much for watching. I really, really appreciate it. Bye-bye. 1, 2, 3, check, check, check. Okay, well, let me see if I can even find some replacement fets for this thing. One moment. Let me zoom out, and then we'll do an ohm check on them. Okay, so... well, I did manage to find a supplier in the United States that does carry a version of the 26NM60N, and it is the, let's see, it's the STP 26NM60N, 600 volts, resistance of 0.165 ohms, 20 amp dissipation. And you can take a look at some of the components of that, and then I have the actual tech sheet right here, electrical ratings. 600 volts, gate source voltage plus or minus 30 volts, drain current 20 amps at 25 degrees Celsius, or 12.6 amps at 100 degrees Celsius. So that's boiling 212 degrees right there. Drain current pulsed, and I don't think I have the number 1 note, 80 amps. Total dissipation at 25 degrees Celsius is 140 watts. Which is perfectly fine. There's some other information if you need it. So I'm going to go ahead and contact the customer and see if he wants to proceed with trying to slam some new fets into this unit. Oh, double-sided tape is still on the bench. Huh, I forgot about that. Anyhow, there you go. So this will be part 2 of the definitive Technology SuperCube 4000. All right, hopefully there'll be multiple more parts to this unit. Everyone, thank you for watching. I really, really appreciate it. Go ahead and have a great day. Everyone, have a great day. Thank you so much for watching once again. Bye-bye. Everyone, have a great day. Bye-bye. All right, let's take that again. Check, check, check. 1, 2, 3. Check, check, check. Okay, well, before I go much farther, like I said, I'm going to go ahead and do some research and see if I can find a good quality, either DigiKey, Mauser, or Newark US supplier that has these fets in stock, because I don't want to get burned on this thing and not be able to get the replacement parts that it needs. I don't like doing substitutions. I've had issues where if the capacitance is different, it causes the turn on, turn off time to be different, and I just don't have time to basically re-engineer this thing, change component values and capacitor values to make it operate. So I need to make sure I can actually get the replacement output fets Q1 and Q5, and then I'll have to try to find a suitable replacement for these little driver transistors, which shouldn't be too terribly hard. They're just basically transistors. That's it. I'm not even sure. I didn't do the math to figure out if they're NPN or PNP, but we'll cross that bridge very shortly.